A quick nod to the people involved in the project, the Saltmarsh Restoration Project, and also a quick nod to the funding partners of the Estuaries Partnership. Okay. We have 5 estuaries in South Devon, AONB. They are all Ria-type estuaries. So these were riverbeds carved out through the last ice age, and then as the sea levels rose, flooding these river valleys. So in fact, nearly all the estuaries in the southwest are these Ria-type estuaries, meaning that they are deep, narrow and steep-sided. And that's why our salt marshes are similarly long and narrow, because these, as you'll see, are ecosystems that form along the edges of the estuaries. To explain something about salt marshes, we need to understand our shores. So the foreshore is an area that's covered and uncovered twice a day by the tides, as you'll realise. And when you see a man-made structure like this, you can see the impact of that on the zones on the foreshore. So the foreshore is quite a difficult place to live. Everything that lives there has to be is exposed to whatever's happening with the weather twice a day, and of course is flooded by the salty waters. And those two things have a massive impact. Almost everything on the foreshore is marine, and they are kind of tolerant of fresh water more than land plants and animals that have moved into the sea, because salt is toxic to so many things. The seaweeds at the bottom have the easiest life. You know, they're only exposed for part of the day. The seaweeds right at the top, they're exposed for most of the day. So they have to be really hardy. So this is why you get these stripes. On shallower bits of foreshore, on a different kind of sediment, we start to get the salt marsh, right at the very, very top of the foreshore. Indeed, it's an area of the foreshore that isn't covered by the tide every single day. If an area of foreshore is covered by the tide every day, every tide, then it's dominated by the seaweeds. So you get the salt marshes above that. So you can see it here quite nicely. There is one salt marsh plant that will tolerate being flooded with every tide, but all of the rest of them, you know, it's just a delicate balance. Some of the salt marsh plants will tolerate being completely inundated with water. Some of them will only tolerate getting their roots wet. Interesting thing about salt marsh plants is that these are particularly salt tolerant plants, and it's the salt that is kind of affecting them most. If it wasn't for the salt, the land plants would be able to migrate down and outcompete them. What's particularly interesting, I find, about these plants is the mechanisms that they have to be able to deal with or tolerate this salt. And they have mechanisms to exclude the salt in the first place. So they may have other salts that sort of have that osmotic pressure to keep the salt out. Some of them actively have glands to pump the salt out of them. Some of them are kind of fleshy and succulent, so they have more water in them. Maybe this just dilutes the salt that does get into them. And then there's also passive removal. So some plants actually divert the salt into older leaves and then discard those leaves. Other plants have a very short life cycle. So long as they can get to the stage of flowering and producing seed, they've done all they want to do. So even though the salt might catch up with them and kill them, so long as they've set seed, they're okay, they're happy, they've done their thing. So just a quick look at a few of these plants. This is rock samphire. No, it's not rock samphire, it's marsh samphire, sorry. I always get confused about the two. But it's also known as glasswort. Sometimes if you go to a restaurant, they'll give you this on your plate. It is a perennial one, and it's one of the few salt marsh plants that actually grows more healthily in salt water. We also need to consider reed beds, tidal reed beds. These can be very salt tolerant too, and they're an odd one because they will also grow very healthy reed beds in entirely freshwater conditions. And they seem to grow particularly well where the salt floods over their roots, but there seems to be an upwelling of fresh water at the same time. Other places you get the more traditional looking salt marsh. This is the poster child of the salt marsh world, the sea aster. To all intents and purposes, it looks very much like some of the flowers that we have in our gardens, and I could think of the name 2 seconds ago and now I can't. That's great, isn't it?
Michaelmas daisies.
Michaelmas daisies, thank you so much, that's the ones. Yeah. And we shouldn't forget either that these are a whole ecosystem. They're a whole community of wildlife. It's not just as plants, but animals too. And because of the tide sort of coming in and out, a lot of the animals that enjoy these salt marshes have to migrate in and out with the tide. So when the tide comes in, there's a number of fish that will go and enjoy the shelter amongst the salt marsh. If you can see here, these parallel lines in the surface of the mud made by grey mullet that feed on diatoms on the surface of the mud, and they make these double lines. You get things like crabs that will either hunker down into the mud, or they may sort of migrate to some extent as well. And then there's quite a number of insects. I didn't, as a marine biologist, I didn't normally think of insects as being tolerant of salt water, but there's actually quite a number of insects that do thrive in these salt marshes. Probably not down amongst the seaweeds, but certainly within the salt marsh. Salt marshes are reasonably seasonal, so right now they're probably in their worst condition. The plants have died off, and I'm afraid they don't look very sexy. Give it a few weeks, they green up, and the flowers will come out, and that's when to see them. That's when they look most attractive. And part of our project is to get people excited about salt marshes. And now is probably not the best time to be doing that, but there you go. So, in the words of Monty Python, what have salt marshes ever done for us? Well, quite a number of things actually. They improve water quality. I don't mean they sort of zap all the bacteria or something, but they mop up some of the nutrients. And they also, because of the way that the plants stick out of the water, they slow the water down when it gets in amongst the salt marsh, and that causes all the organic material to settle out, so they trap a lot of material. They enhance their biodiversity. Estuaries are funny places. They have a relatively low diversity of wildlife, but that wildlife that can thrive there are there in stupidly big numbers. Food provision, probably not so much of a thing in our southwest estuaries, but more of a thing on these big, wide expanses of salt marsh that you have in the places like East Anglia. Flood and coastal defence, again, it's that buffering, that slowing, buffering the waves as they hit the side that just help protect the shores. Recreation and well-being. As we paddle around, as we enjoy their estuaries, we like to see these green edges. We like to see the trees beyond. So they just add that extra something. They help with fisheries production. A lot of fish, commercially important fish that we eat, they will spend their time in estuaries during, as egg-laying grounds and nursery areas for young fish. And as the tide comes in, bringing in the predatory fish, these smaller fish will go up into the salt marshes or in amongst the seaweed to hide. As I mentioned, with improved water quality, they mop up some of the nutrients from our estuaries. And also, hugely importantly, as carbon sinks. So when you look at that, for one thing, being plants, they take out carbon dioxide and they assimilate that into the plants themselves. And when the salt marsh plant dies, that carbon then gets trapped within the mud. But because of this 3D nature of salt marshes trapping that detritus, they actually trap a lot more carbon than just that they sequester themselves. And that's, layer upon layer over hundreds, if not thousands of years. There are parts of our estuaries that are maybe 10, 12, 15 metres deep. They lock up a huge amount of carbon, and the salt marshes are one of these places. Now it's reckoned that our salt marshes can trap more carbon than forests. So we need to be very careful with these graphs and things, making sure that we're comparing apples with apples, not apples with pears. So look very carefully, what is the graph showing you? The amount of carbon that's sequestered, the amount of carbon that's trapped, or the amount of carbon that's locked away. But salt marshes, seagrass beds, estuary mudflats, all hugely important for the amount of carbon that they lock away for millennia. And that's why sometimes salt marshes can look less attractive, because they attract and trap all this detritus. To our eyes, it's twigs, it's leaves and everything else, flotsam and jetsam, but it also means that they trap a lot of litter. So I'm afraid salt marshes can look less attractive because of the amount of litter that they also trap. But that's a modern day thing. Traditionally, it would have been just twigs, leaves and the likes. So what can we do to protect them? Very often they will have these kind of steep edges, and you get some wave action that will undercut them. But this is a natural kind of cycle. But our activities and our boats, if we make too much wake, we can sort of make it that much worse. Things that we can do, this is in the Devon say, put down posts, tie them together, and then use natural detritus as a barrier behind, and then you'll get extra accretion of material behind and more salt marsh to stabilise that behind. Sometimes we can actually artificially plant the plants, but then those plants themselves need some kind of protection. So this is a matrix made from potato starch that's been planted up and then anchored in place with stakes. This is something that could be considered in places like Sharper Marsh, not to protect the marsh, but just to add a complexity of habitat. So, just to maybe have some pools of water that are more slowly draining. One of the things about our southwest estuaries, very often we've built seawalls and things, and then if there's a bit of salt marsh in front of that, with sea level rise, naturally the salt marsh would be able to migrate up the shore. But if we have an artificial barrier in the way, the habitat of the salt marsh is squeezed against it, and we all lose out. If at all possible, it's better to move that barrier back so that the salt marsh can migrate up semi-naturally up the shore, and then the salt marsh will have that buffer effect and help. So, if that's called managed realignment, and we've actually, people have actually reckoned that managed realigned salt marshes actually trap more carbon than even naturally occurring salt marshes. I'm not entirely sure why that might be, but it might just be something to do with the rotting down of the original vegetation that's now flooded by the tides. You also need to be careful about, this isn't anywhere on the dart by the way, you need to be careful about development, the use of the foreshore, the respect of the foreshore. I mean, this slide at the bottom, a lot of salt marsh here has been lost because people have been dragging their boats over the top of it because it's softer to their boats. But, you know, that's restricted the light getting to the salt marsh, and that salt marsh has been lost. Or somebody's built a bonfire, and the driest place to do it is right on the top of the salt marsh. We need people to understand salt marsh, why it's important, why we need it, why we need to respect it.
Got 2 minutes, Nigel.
Okay. We might even need to be kind of careful about wildlife and grazing. This, you know, things like Canada geese, they can graze a lot of marsh, and if you walk over the area, it's quite well fertilised by the Canada geese. I'm going to come on to what we're hoping to do from the project, but also with the amount of nutrients that we have in our estuaries, there's a huge amount of growth of seaweed, and sometimes this will smother the salt marsh. One of the things that we need to do as well is to improve water quality, so we get less of this seaweed on the growth. So the Salt Marsh project, initially what we've done is looked at the areas of the Dart using satellite images, identified where we know salt marshes, where it might be, where it might possibly be, and gone back to old maps as well and looked at where we've lost salt marsh. And then just recently we've been ground truthing those areas to see if there is any salt marsh there. So these are tidal pools behind the embankment on the Kingswear side. Actual fact, it looks a bit green, but that's more algae than salt marsh, so not there. And it's probably not worth, you know, the whole problem of getting plants and things there to do anything active there. But other places, you know, we need experts to come along, survey the health of these salt marshes, and then prescribe what conservation management might be suggested to the landowner, because we very, very much need the full cooperation and permission and everything of the landowner to improve these salt marshes, both for biodiversity and their carbon take-up, their blue carbon. So it's traditional to finish on a flowery sunset slide. I'm just unfortunately I don't have one of the darks. So there you go.